2.4 gram of carbon is burned in a calorimeter, given that the heat of reaction for carbon dioxide is negative 394 kilojoule per mole, and the heat capacity of the calorimeter is 10 kilojoule per degree Celsius. Calculate the temperature changes of the calorimeter. Given the information is mass for the carbon is 2.4 gram, and the heat of reactions for carbon dioxide is negative 394 kilojoule per mole. Next is the heat capacity, which can replace by the letter C, is 10 kilojoule per degree Celsius. What we need to find is the delta T. This is negative since it's the exothermic reaction, so we don't need to take the negative in the calculation. And exothermic, because this is burn, it's called burn. To find the T, we can use the equation Q is equals to C delta T. But first, we need to find the Q. To find the Q, we need to know the number of moles for carbon. And we do the chemical equations first. C plus O2, since it burned, and we got CO2. And then we need to know the number of moles for carbon. Equation for number of moles is mass over molar mass. And substitute the information given. Mass for carbon is 2.4 gram. The molar mass for carbon is 12. And then we got 0.2. Within this, we know that 1 mole of carbon, the heat released is 394 kilojoule, and for 0.2 mole of carbon, we need to know the heat release, which is the Q. And then we multiply this. What we got is 1 is multiplied by X equals to 394 kilojoule multiplied by 0.2, and X we got 78.8 kilojoule. And this is the Q we're searching for. To continue this, using the equation I mentioned before, which is Q equals to C delta T, we substitute the information we got. Delta T is 78.8 over 10. Just simplify that, and the delta T is 7.88 degrees Celsius, and that's the answer for this question. Thank you.